So in this video, I'm going to go over the review of the properties of functions that we went over in class today. So first of all, we want to find the domain and the range of this function. So to do that, domain is, let's just say this up here, all the x's, right? And the range is all the y's, okay? So we're looking at our domain in this particular graph. Notice that all our x's go to the left of where x equals 3. So our domain is going to be x is less than 3. Excuse me. And then ranges are y's. So our range is going to be all the values of y. And if you notice, this graph continues to go up over here and it continues to go down over there. So this is going to be all real numbers. And that's the symbol for all real numbers, okay? Then we want to talk about intervals. So we want to talk about intervals of increase and decrease. Okay, so that means when we move in from over here on the left, what's happening to this graph, y'all? Yep, it's decreasing, okay? So this does not have an interval of increase. So we're going to put NA for that, not applicable. And then decrease, where does it decrease from? So when we're talking about decreasing and increasing, we're talking about x's, okay? So it's going from negative infinity here to where? Yep, to that 3 right there. So it's decreasing from negative infinity to 3. That's the range from where it actually decreases, okay? Because this was our 3 right here. Then let's go ahead and talk about end behaviors. So we're talking about end behaviors. We're talking about as x approaches infinity, what happens to f of x? And as x approaches negative infinity, what happens to f of x? Now I want you to remember that f of x is y, okay? So as I head this direction on the graph, where's the y headed, y'all? It's headed towards negative infinity, right? Now, as I head the opposite direction and I'm going this way, what's happening? As I head towards this, because this is negative infinity here, right? This is infinity, okay? So as I head with the x's towards negative infinity, what happens to our f of x? Yes, it's going to keep going up and up and up, okay? So then the last question on this page is, what is the intercepts, okay? So what we're looking for here are where is it intersect? So right there's where it intersects, and I notice that this is -1 right here. So that's between 0 and -1. So I think that this is at 0, -1/2. And there's probably one somewhere out here, but I can't see it, so I can't write it on here. Oh, let me go back. This graph was a log graph, okay? So this is a log of x graph. Now, there are some other things involved in it, but this is a logarithmic graph, okay? So our next one is a square root graph, okay? So on this one, again, we're going to talk about our domain and range. So our domain, remember, is our x values. So do you notice that our x values start right there? So when we're talking about our domain this time, our domain is going to be x is less than or equal to 3, because that's 3 right there, okay? When we talk about our range, that's our y values. So notice here, that's where our y values start, are at 2. And they go down from there. So we're going to say y is less than or equal to 2, okay? The next thing we wanted to know were intervals of increase and decrease. So we're going to talk about increase and decrease. And I'm going to show you here, actually, I'm going to show you here, and then I'm going to go back to the previous slide and show you the connection there as well. So when we're talking about intervals of increase and decrease, again, we want to look at moving from left to right, what's happening to this graph. Yeah, it's rising, right? So this is an interval of increase, and it goes from negative infinity to where? To that 3 right there. So it goes from negative infinity to 3. And then does it have an interval of decrease? The answer is no. So it's not applicable here, okay? So I want you to notice something here, guys. you should see a connection between this and this, okay? So our domain is going to affect our intervals. If there's a number in the domain, then it's going to show up in our intervals of increase or decrease, okay? Now we're going to talk about as x approaches infinity, what happens to f of x, and as x approaches negative infinity, what happens to f of x, okay? So that's what we're asking right here. So now, again, let me erase this so I can talk y'all through this. So as we approach infinity over here, so we're going this way on our graph, we're going to the right, okay? So we're going this way on the graph, whoa, what happens right there? Doesn't it, our f of x stop? So it's approaching 2, notice that? Then as we go the opposite direction, where's the graph headed, y'all? Yes, towards negative infinity, okay? So here you should see a connection between these two, okay? So let's go back to the previous slide so I can show you that there too, okay? Again, notice our domain shows up right there, right? And our range, it shows up right here, because if the range was all real numbers, then obviously this graph is going to go all the way to the left and all the way to the right, and it's never going to stop. All right, so let's do our next. Oh, we need to do the intercept of our function, okay? So there are actually 2 of them here. One of them's right there, and one of them's right there. And notice again that this is 1. So this intercept right here is at -1, 0. And the other one is, I would say it's about a 1/4, because this right here is 1/2. So let's just say that that one is at 0, 1/4, okay? All right, so this next one, this is a cube root graph, okay? So again, our domain, do you see any restrictions on our x values? Me either. So this is going to be all real numbers. And our range, and what you guys need to be thinking of is, like, there's arrows here, right? So that thing's going to keep going to the right and the left, and it's going to keep going up, and it's going to keep going down. So both our domain and range for a cube root function is going to be all real numbers. Then we're going to talk about increase and decrease. So once again, let's look at this graph. So we're going to move in on it from the left and move to the right. So what do you notice? What's happening with this graph the whole time? Yes, it's increasing. Now notice there's arrows on both ends, right? So it's increasing from where? Negative infinity to infinity, and it did not decrease at all. So we're going to say not applicable again. Now we're going to talk about as and behaviors. X approaches infinity, f of x approaches. So as we go to the right, where's this graph headed, y'all? Yep, towards positive infinity. And as x approaches negative infinity, f of x approaches what? So now as we're going over here, what's happening? Yeah, it's going down. So it's negative infinity. So here again, let's look at the 0 or the intercepts of our function, and it looks to me like the intercept's right there. This is 4 right here, and this is 6 right here. So that looks to me like it's at 0, 5. Now, again, I dare say there's going to be an intercept over here somewhere, but we can't see it, so we can't write it. All right, so this one is an exponential function. So this is going to be a b to the x power. And this one actually would be, this number is going to be a fraction, because this is a depreciation function, okay? So once again, remember there's an arrow here and there's an arrow here. So domain, what do you notice about the x values? Any limitations? Nope. So that's all real numbers. And then our range, what do you notice about our range? What do you notice about the y values? You should notice that all of them are above the x-axis, right? So y is going to be greater than 0. And that's always going to be true of growth and decay functions, okay? So then we want to talk about intervals. So interval of increase, interval of decrease. Okay, so once again, going to hop on the graph right here. What's happening to the graph, guys? Yes, it's decreasing. So our increase is going to be none or not applicable. Decreasing from where? Okay, so again, remember, there's a connection right here between domain and these two, right? So if it's decreasing from where? From negative infinity to positive infinity, because that's all real numbers, right? So then we're going to talk about as x approaches infinity, what happens to our f of x, guys? As we go to the right on this graph, okay, what's happening to the y? F of x approaches 0, doesn't it? So here again, remember this connection, okay? Then as x approaches negative infinity, now we're moving to the left. What's happening to f of x? So now we're going this way, right? Isn't it headed up towards infinity up here? It is. Okay, so now let me erase all this so you guys can see where the intercepts are. Hopefully you can see the intercept is right there. So that is what? 0, 2. And again, remember, it's never actually going to touch that x-axis, okay? All right, so this one. Now, everybody should know this one. I can actually even write the function for this one. So this is f of x is equal to, remember our slope, 1, 2 over 1. So that's 2. And there's our vertex right there. So this is going to be x minus 4. Whoops. Sorry. And then it's going to be, see that right there? Minus 8. That's actually our function if we had to write it. Then, again, we're going to talk about our domain and our range. So what do you notice about the x values? Any limitations? Nope, because the arrows are pointing to the left and the right, right? So this is going to be all real numbers. Now, but what about our range? Do you notice the graph is all above there for the y values? So y is going to be greater than or equal to negative 8. So this time, increase and decrease. We're going to have one of each, aren't we? So we got an increase and a decrease this time. So let's talk about where these are. So as I jump on the graph over here and I move this way, what's happening? Yes, it's decreasing. To where? So this was negative infinity, and this is 4, right? So it's decreasing from negative infinity to 4. And then what happens here? What's going on now? Yep, it's increasing. Y'all see that? And it's increasing from where? From 4 on to infinity. Then let's talk about as x approaches infinity, what happens to f of x? So as I'm going, let me go ahead and erase this so you guys can see what I'm talking about. So as I'm going towards, as I'm going this direction with x, what's happening to y, y'all? Yes, it's approaching infinity. Then as x approaches negative infinity, what happens to f of x? So this time we're going this way, right? What's happening to it again? Yeah, it's still approaching infinity, isn't it? Still going up, okay? All right, so finally, let's talk about our intercepts. So it looks to me like there's two, one right here. So this one is 0, 0. And another one right there, which is 8, 0. Remember, intercepts are where the graph intercept either the x or the y-axis, okay? Now what I'd like to do is I'd like to go over one more concept, actually two more concepts with y'all. So I want to go over this. This is, and I'm going to do this with the square root just to refresh y'all's memory. Okay, so I want to talk about what all these are. Okay, so when I have an A, if the A is negative, that means it's a reflection over the x-axis. And if you guys don't have this in your notes somewhere, you want to write it, okay? When A is between 0 and 1, this is going to be a vertical, that means it's a fraction, right? It's going to be a vertical shrink by a factor of whatever A is. And then when A is greater than 1, it's going to be a vertical stretch, again by a factor of whatever A is. S-T-R-E-T-C-H. Yep, could be great if I could spell, huh? Then let's talk about this B. Okay, so now when B is negative, if A was a reflection over the x-axis, what do you think a negative B is going to be? A reflection over the y-axis. Okay, and then when B, now notice that it's 1 over B. So when we're talking about B being between 0 and 1, this time it's going to be a horizontal. And listen, it's not going to be a shrink, it's going to be a stretch because it says it's 1 over, it's going to be inverted. S-T-R-E-T-C-H. Be great if I could write, huh, y'all? And then when B is greater than 1, this time it's going to be a horizontal shrink. Again, by a factor of whatever B is. Okay? So then we have our H. Hopefully you remember that when H is positive, it's moving left because it's really negative. And when it's negative, it's moving right. And then finally, when K is positive, it's moving up. And when it's negative, it's moving down. Okay? So I have one more thing I'd like to talk to y'all about. And that is what was on the Unit 12 test. So when it talks about the recursive formula, y'all, a lot of y'all missed this on that test. What it's talking about is us taking our ratio, and we get our ratio by doing what, y'all? By taking our second term and dividing it by our first term, okay? So when we do this, it's going to be the ratio times a to the n minus 1. And what does that mean? That means every term, we're going to take the previous term and multiply it by our ratio to get the next term. So this means previous term times ratio to get the next term. That's what the recursive formula does for you, okay? So you find the ratio and then you put it next to the previous term to get the next term. Then we have the explicit formula. This formula was when we took A1 and we multiplied it by ratio and do it n minus 1. So what does that mean? So that means, hang on a second. That means that when I'm looking for a to the n, which is some number, it could be 10. That means I'm going to take my first term, that's what a to the first is, and then I multiply it times the ratio to whatever this n was, minus 1. That's how we find a specific or explicit term in the series, okay? Now, when it's talking about sum, y'all, it's talking about the sum of the first term through the nth term. Okay, that's what it's really talking about. So that looks like this. S of n is equal to, again, we're going to take our A1 and we're going to take 1 minus our ratio to the nth power this time, and then divide that by 1 minus r. Okay, so this is when we're looking for the sum of, let's say n was 10, the first 10 terms, okay? And then you also have the infinite sum, okay? This is a different formula, so you guys have got to read these questions, okay? So with the infinite sum, you're going to take A1 and you're just going to divide it by 1 minus r, whatever the ratio is, okay? So A1, again, remember, is the first term. Anytime y'all see A1, let me put that over here. A1 equals the first term, okay? R equals your ratio. N has to do with the term that that is in question, or the number of terms in the series, okay?